Which is heavier, 1 kilogram of bricks or 1 kilogram of feathers? You might have heard this trick question before, and the answer should be obvious after watching the units video. The answer is they both weigh the same. They both have a mass of 1 kilogram. But the brick intuitively feels heavier than the feather. And if you threw both of them into a lake, the brick would sink, but the feather would float on the water surface. And that's because of a property called density. Density is a measure of how much matter fits into a space or volume. Density is defined as a ratio of the mass of an object to the volume that it occupies. In formula form, density is represented by the Greek letter rho and is equal to the mass divided by the volume. Since mass has a unit of kilograms and volume is a three-dimensional measure of length and it has a unit of meters cubed, then the density has a unit of kilograms per meter cubed. Let's go back to the brick and feather problem and apply the concept of density to it. The density of common red brick is about 1,900 kilograms per meter cubed, while the density of feathers varies depending on the type of feather, but it's in the order of about 2.5 kilograms per meter cubed. So let's use this value. Now let's work out how much volume 1 kilogram of each take up. If we take the definition of density and transpose the equation to solve for volume, we get volume being equal to the mass divided by the density. For the brick, the mass is 1 kilogram and the density is 1,900 kilograms per meter cubed. That gives us a total of 0.0005 meters cubed. As for the feather, using its density of 2.5 kilograms per meter cubed, we see that 1 kilogram of the feather takes up a volume of 0.4 meters cubed. This is substantially bigger than the volume of the brick for the same mass. 800 times more space is needed to fill the same mass of feathers compared to the brick. Let's look at the problem in another way. Let's consider 1 cubic meter of brick and 1 cubic meter of feathers and work out how much mass there is. Transposing the density equation for mass gives us mass being equal to the density multiplied by the volume. So for the brick, it's 1,900 kilograms per meter cube multiplied by 1 meter cube to give us 1,900 kilograms, or 1.9 tons. And for the feather, it's 2.5 kilograms per meter cubed multiplied by 1 meter cube, or 2.5 kilograms. So we can see that 1 cubic meter of brick will be substantially heavier than 1 cubic meter of feather. So we've defined mass density in terms of an object's mass and its volume. Volume is a measure of three-dimensional space. For a regular shape, like a rectangular prism, its volume is a product of its height, width, and length. For a cylindrical object, its volume is the cross-sectional area multiplied by its length. There are many cases where the cross-sectional area is constant and the length may vary. Examples include wires, which have constant diameters that are defined by the gauge number, or structural steel beams and columns that have defined widths. In these cases, where the cross-sectional area is constant, it's common to see their densities defined in terms of the length only. This is called the linear mass density and is written as a mass divided by the length and has a unit of mass per unit length. Take for example steel columns used in the construction industry. One such column has a name 150 UC23. This column has a standard dimension of 152 mm by 152 mm and the thickness of its web and flange is about 6.8 mm. For this column, the mass is defined in terms of its unit length, so a linear density is often quoted instead of its volumetric density. The column is made of structural steel, which has a density of around 7,850 kilograms per meter cubed. But when calculating its mass in a construction project, its mass density is given instead as 23 kilograms per meter. In summary, Mass density is defined as a ratio of an object's mass to its volume and has a unit of kilograms per meter cubed. In some industries, it's convenient to use linear mass density instead, which is the mass of the object divided by its length and has a unit of kilograms per meter.